Alright guys, so in this video we're going to talk about our last few types of graphs. So we mentioned histogram versus bar graphs in the last class, and now our second type of graph is going to be our scatter plots. And so scatter plots are going to be really important because they show the relationship between two sets of data. And the reason that they show the relationship is because I plot these on an XY coordinate. Typically, we'll only have one quadrant being displayed because it's normally real data like time or hours of sleep or number of jackets. And so those things aren't typically negative. So it's very common that you'll just see quadrant 1 where we have the positive x-axis and positive y-axis. So with that being said, our horizontal axis is going to be our x-axis, and then our vertical axis is going to be our y-axis. Where those two intersect, we call that the origin, and that is the point 0, 0. And so we have a couple of different types of correlations or relationships, as we called it previously. A positive correlation is going to be another term for that. It's going to be directly related. And what that means is as one increases, the other increases as well. And over here, we'll see some examples specifically of these. But a direct relationship is going to have this graph. It is going to be generally going uphill. Now, it's not always every single point is going uphill, but generally the trend is going to be going in the up direction. And just to note, we do read graphs from left to right just like we would read words. So when I say uphill, I mean that it is going uphill from left to right. Negative correlation is going to be an inverse relationship, and what inversely related means, as one variable goes up, the other one is going to go down, or as one data set increases, the other data set is going to decrease. And like our positive correlations, unlike our positive correlations, these will be going downhill from left to right. So they've got this general downhill trend. And then, of course, it is possible for a no correlation, that the two data sets are not related at in any way. So let's look at these examples over to the right, however you have them on your paper. Education and income. So theoretically, and in general, as your education increases, so does your income, theoretically. So as one increases, the other increases. And so we're going to call that a positive correlation. Number of pets a person has and the number of books a person has read. So as the number of pets increase, does that say anything about the number of books you have read? No, they're not related. So this one is going to be a no correlation. Number of days absent from school versus math average. So as your absences increase, your math average is probably going to decrease on average. And so that is going to be a negative correlation. Test scores versus shoe size. Well, can we say that as our test scores increase, that says anything about the shoe size? Nope. So that's going to be a no correlation. Distance traveled versus amount of gas in the car. So as I travel, as the distance traveled increases, I travel further or I travel more, the amount of gas in my car is going to decrease. And so that one is going to be a negative correlation. Hours studying versus grade. Well, theoretically, as my hours studying increase, so should my grade. So that one is going to be a positive correlation. Hours in the mall versus amount of money spent, theoretically. So theoretically, as I spend more hours, we could say in Target or Sam's Club for me. If I spend more hours at a store, I'm probably going to increase the amount of money that I plan on spending. And so that is going to be a positive correlation. Weight on the skateboard and the speed of the skateboard. Now, we are assuming that the skateboard is on flat ground, not like going downhill with any other force. So as the weight of the skateboard increases, the speed of the skateboard is probably going to decrease. And then a person's height versus a person's age. We'll think about newborn babies all the way up to, say, teenagers. As the person's height has gone up, right, from babies to teenagers, so has their age. Now, if we were just looking at a snapshot of 12-year-olds, there would not necessarily be any relation to the height of different 12-year-olds related to their age, but I'm thinking of this kind of across the lifespan. So across your lifespan, as your height has increased or as your age has increased, so has your height. So we're going to call that a positive correlation. How tall a person is and how fast they drive. Well, can I say that as you increase your height, you increase or decrease your driving? No, not necessarily. Oh, excuse me, not negative. No correlation. And then the temperature versus number of jackets people are wearing. So as the temperature increases, the number of people wearing jackets is probably going to decrease. Likewise, if the temperature is decreasing or getting colder, the number of people wearing jackets is going to increase. And so that one is going to be an example of a negative correlation. All right, our last three types of graphs, I just made some examples. I truly just made these up. Just made some examples so that you could kind of see what they look like. We will talk more about them in class, and then we'll also talk more about them in Math 212 in much more depth. And so a line graph is going to be very useful for showing trends over time. Typically over years is when we're going to use our line graphs. So we could look at this, my example, the weight of my pet dog, and see that overall the weight is increasing. So we're assuming that my dog is growing healthily. Second one are pie charts. Pie charts are going to be very useful in showing parts of a whole. Typically that whole is going to be 100%. So this is very common to break down percentages. And again, I just made this up. My favorite, or I interviewed people, their favorite colors. And so you can see that I've got this breakdown and a nice visual where I could really quickly look at the majority of people like this, the least amount of people like this, those type of things. Thirdly, our stem and leaf plot. Stem and leaf plot is going to be very useful because it actually shows the data itself. All of these are looking at more of trends or an overview. The stem and leaf plot is going to show you every single data piece. And so with our stem and leaf plot, we have this idea that the stems are 1 digit on the left, the leaves are 1 digit on the right. So not always true. The stems can be more than 1 digit. We just don't have that in this example. The leaves, though, always have to be 1 digit. So the leaves must be 1 digit. The stems are everything else. And then you do have to have a key. This key just tells your reader what is it that they're looking for. So I just made this up, age of students in ED 102. So we can see that this right here, a 2 and a 0, that means that that particular student was 20. Or we have a 2 and a 3, that particular student was 23. And 28, 32, 34. Notice that if you have multiple data sets, you do write them all. And then if you don't have anything, you do still have to have that stem in there just with no leaves. Do not put a 0 in there because then that implies a age of 40. So we just leave it completely blank.